Okay, we are reviewing for a cumulative test. The cumulative test covers 4 sections. Algebraic manipulation, number 3, and that's the one you just took. I'll hand that back later today. So let's skip that one, turn the page. Everybody look at the second page of the packet. It says this section covers communication number 2. Communication number 2 is a part. The top of the next page says communication number 3. And the last part of the packet says graphing 3. Okay, so there's 4 major parts to this test. We will not spend very much time on the algebraic manipulation number 3 because it's the one we just did, and it should be freshest in your mind. All right, and what we do on that, I'll do later after I hand back your tests. All right, let's look at communication number 2 then. Problem 8 in your packet. It says, write the statement as a power function. Power functions. Do you remember those? I'll give you a quick reminder. Okay, so a 2-second reminder problem here on power functions. Is this a power function? Yes. And do you remember we would define certain things as constants? We would say, like, let k be a constant. The common constants were k and pi and sometimes m or something like that. All right. So if k is a constant, then for sure that's a constant. Duh, it's a constant. It's a number. That's a constant also if we define k as a constant. So this part's my constant. That leaves what's the other thing? If it's not a constant, it must be a variable. So x must be the variable. And if it's the variable, then whatever the power is the power of your power function. We'd usually just call that p. The power is 2 in this case. And what would the constant be? The constant of variation. COV is what we'd usually abbreviate that. Come on, don't overthink this. 2k. That's the constant of variation, and that's the power. Now I'll make it a little more complicated. Y equals 1 k over 2m to the third. Okay, the first thing you should ask yourself is what's the constant? And then you should move the variable up to the top if it isn't already. And in this case, hint, hint, the variable isn't on the top. So you should be able to tell me 2 things, the P and the COV, the power and the constant of variation. Would you please answer this one? And then have your iPad out, everybody, please, because I'm going to ask you to do some billboarding today where you turn it my way and I'll tell you if you're doing it right. It does 2 things. It tells you if you're right or not, and it gives me a sense of how many kids are getting it and how many kids aren't. So have a Notability doc open on your iPad. And then when I ask you to turn it my way, make sure you zoom it in so it's big. I'm going to have fairly smallish answers that I'll do the turn it my way thing on. So would you please figure out, if you can, what the power and the constant of variation are. And remember, you've got to move the variable to the top before you determine what its power is. Yes, sir. Nice job. Yep. Yep. 3 people know it. I got a glare. Can you tilt it? Yep, you got it. Good job. Your constant is missing something. Yep. 6 people have it. Your power is not right. Don't make it a fraction, make it negative. Yep. Your power is messed up because when you move it to the top, the power changes. Does that help? I don't know. We'll see. Your constant is messed up because there's more to the constant than you have on your screen. Where'd the 2 go? Good. Good. Your constant is messed up At least it's got a 2 in it, but the 2 does not move. The 2 does not move up to the top. Yes in the back with the yellow. Yes. That's a good constant. Now what's the power? You gotta tell me the power also. Good, 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 good. But when you move it to the top, it changes. And now you've got to remove the variable because the variable is not part of the constant. All right, so here's what I wanted you to learn from this or remember from this. This guy has to go up to the top, and when he does go to the top, it becomes an m to the negative third. So now here's my new expression. And this part right here, that's all the constant. The 2 does not move to the top. The m and the 2 are not like permanently joined. So that's the constant, and that part right there is the power. A lot of people put the variable in with the power, and it's wrong. So make sure you include only the negative 3. All right, now let's try the kind where you have to actually write one of those. In Einstein's E equals mc squared, okay, one of those things, if you think it through and you know what those are, m and c squared, one of those things is the constant, and one of those things is the power, okay? I'd like you to tell me what's the power and what is the constant of variation in E equals mc squared. Now, this is kind of a trick question. I'm going to tell you right now that c is the speed of light. That should tell you more about which one's the constant and which one's the power. You got it. Close. Your constant is messed up. Yes. Nope. You assumed that the c was the variable because you said that squared was the power. Squared is on the c, and the c is actually the constant. Yes, yes. You zooming in a little more? Yes. Yes. Close. Your constant has something else on it. Good, good, good. Yep. Your power is wrong because you took it off of the constant. Power can only come from the variable. Good, good, good. As long as that's not a negative one, is it? Okay. Good, good. Okay, good. Now people are catching on. If that's the speed of light, it's a constant. The constant is getting squared, but that doesn't mean the power is 2. If this is the constant, then that means that's the variable, and we wanted its power. So the power would be 1, and the constant of variation would be c squared. Here's the way to think of it. Once you've figured out what the variable is, everything else is the constant. If this is the variable, then that whole thing has to be the constant, including the squared, once you've pulled the variable off. All right, now let's try to write one where I'm going to say a situation, and you're going to write me one of these things. Okay, there's a famous science one that says that the force is dependent upon the mass and the acceleration. And we're going to say in this situation for this problem, our mass is fixed at a certain mass. It's always going to be 1 kilogram. And tell me a power function for that situation. And tell me what its power and its constant are. I said that mass was going to be constant. I think I did, didn't I? Okay. Yep. 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 The constant is the mass. Yes. 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 Okay. So that one, F equals ma, where the power is 1 because the mass was, in this case, constant. We said it was going to be 1 kilogram all the time. So that means that's the constant. That's the variable. And what is the power on that variable? It's a 1. Okay. Now, I probably actually did this one incorrectly, science-wise, because I was just realizing that A is acceleration, which I think is actually the constant. I think that that might be the constant. So if acceleration was truly the constant, that would make this the variable, which would mean that the power is still 1 because it also has a 1 on it. All right, let's do one where there's actually a division involved and stuff. The formula for a certain battery is based on 4 times the perimeter of the battery divided by 3. I'd like you to write me a power function for that. I'm not even asking you to name the power and the constant of variation. Just tell me a power function for that. Okay, it's based on the perimeter. I'm going to call it P for perimeter. Okay, and I said it was 4 times the perimeter divided by 3. And what was the original thing? Was it like energy, or what did I say it was? What? Battery? B for battery? Okay. Could be an E for energy in the battery. It could have been another P for power, which wouldn't be that good. But all right. Now, I want to make one where the P goes on the bottom, or the variable goes on the bottom. You know, remember when we did one like this, and I had like the variable down here? All I want to just tell you or remind you is that if I had one like this, I would be saying that these are inversely correlated. Okay, I would say that this, let's say this is B for the battery, or I'm going to change to E for energy. If I had this one, my energy is inversely correlated with the mass. As soon as they say inversely, you know your variable has to be on the bottom of the fraction. Okay, so this again, the problem would have been if energy and mass are inversely correlated and have a constant of variation of 4/5. There's your constant of variation of 4/5. And since I said it was inversely correlated, the variable has to be on the bottom. Okay? Okay, I feel like you're spending a lot of time on the first 2 questions. All right, let's talk about, if I give you 2 points, I hope you remember that process for, if I give you 2 points like 2, 3, and f of 5 equals 1, which really means 5, 1. If I give you 2 points like that, do you know how to write the equation that goes through those 2 points? We've been doing it on the top 20 forever. Y minus y sub 1 m times x minus x sub 1. Okay, and you find the slope between these 2 points, and you put it here, and then you pick one of your 2 points, and you put it, let's say, 2, 3. Oops, x is 2, so I put 2 here, and a 3 there, so it'd be y minus 3 equals the slope. And what's the slope on this? Well, I go rise over run, so I go 1 minus 3 makes negative 2, figuring out the slope here, over 5 minus 2, which would be 3, so negative 2/3. X minus 2. That's just a quick reminder on how those work. Okay. Vertex form. You remember completing the square? To complete the square to find vertex form, do you remember that part where we do half and square it? I'm going to make this a nicer number just so it works nicer. Let's say it's x squared plus 8x minus 5. Let's do a couple complete the squares. I'm going to do the first one just to remind you, because this test, if I remember correctly, had a ton of find the vertex or find the axis of symmetry, which is based on the vertex. So if you want to find the vertex, you need to complete the square. You remember this process where I move the minus 5 over, and then I take half and square? What's half the 8? Yes, the little German boy half and square. So half of 4 is 8, or 8 is 4, and then I go 4 squared is 16, and if I do a plus 16, I got to do minus 16. Remember this? And then this part right here gives me the perfect square part, and that's x plus 4 and x plus 4. And then this part right here gives me the final answer on negative 21, and then I'd go y equals x plus 4 squared minus 21. So there's my vertex. My vertex, remember this is opposite, negative 4 comma negative 21. Because the stuff on the inside is counterintuitive. You don't take 4, you take negative 4. All right? Does that ring a bell? Okay, then let's try a complete square. Everybody do this one with me. X squared plus 10x minus 3. Do completing the square to tell me what vertex form is. And there would be a follow-up. What's its axis of symmetry? First you find the vertex. The axis of symmetry is just right there. Once you've got the vertex, the axis will be easy. First step always, move the minus 3 all the way over. Turn it my way when you think you have it. The equation in vertex form. Got to put the negative 3 on there. Yep. Don't put the vertex on there. It confuses my eyes. Just write it in vertex form. You need an equals in there, but otherwise you're good. Yes. You need a y equals at the beginning, otherwise you don't have an equation. Yes. Yep. Good. A lot of people doing this right. Half and square, half of 10 is 5. 5 squared, 25. And then you go minus 25. This part factors perfectly, so you got y equals, I'm just going to jump right to it, x plus 5 squared. There's 2 of them, if you wanted to write it out. These together make minus 28. All right. That was too easy to be an R3. That could be like an R2. Okay, now here's how it becomes an R3. What if it says this? Now here's the thing that's complicated about this one. You still move the minus 1 all the way over. Everybody do this one with me, please. But we've got to factor something out of the first 2 terms. Some people have this messed up idea of factoring that you can't factor just part of it. You can. That's what we're going to do. We're just going to factor the first part here. And a 2 comes out of it. Now I know you might know that x could also come out, but then we won't have a quadratic anymore. And then, inside the parenthesis, and then it won't work. So all I want to do is factor off whatever number is on the x squared, factor it off. So that 2 comes off, and I have x squared plus 6x. Still have a minus 1 way over there. Now that you've got that factored off, it's the same process as it was before. You do half and square. You figure out, and just don't forget this little 2 in front gets factored in elsewhere. See, half of 6 is 3, 3 squared is 9, so plus 9, and here's a minus 9. Do you remember what to do with that 2 that everybody forgets on this problem? Yep. Because this 2 will get multiplied by this 9, and these 9s were meant to counteract each other, This 9 has to also get multiplied by the 2 in the front. So, final answer, y equals 2x plus 3 squared. And then that makes negative 18. That makes negative 1, makes negative 19. And now my vertex becomes clear. Negative 3, negative 19. Now one more thing. What if they ask you for the axis of symmetry? The axis of symmetry is the line that runs right through that vertex. If that vertex is at negative 3, negative 19, it's way down here. Do you get the parabola looks like this, and the vertex is going to run right through that spot? It's the x of that. So it's this. So you'd say x equals negative 3. That's the axis of symmetry. Okay? Now, I know for some of you that are watching this video and are like, wait a minute, my teacher never did this. It's okay. There's another way to find the vertex, and I'll just show it real briefly. The other way to find the vertex is the vertex x is given by negative b over 2a. And negative b would be the opposite of 12, which would be negative 12 over 2a, which is 2 times the 2, which is 4, which makes negative 3. And now that I know the x of the vertex is negative 3, which we can verify, see, we did it this other way and we knew that, then I can take that and put it in for the rest of the equation back in here. I put in a negative 3 and I work it all the way out, and that'll tell me my y of it, which turns out to be negative 19. So that's another way to do it. I personally like this completing the square thing. I think it's great algebraic practice, and I've talked to a couple calc teachers who said that it's great algebraic practice for you. If you'd rather do it with the knowing that x equals negative b over 2a, and that tells you your x of your vertex, I'm fine with you doing that. In fact, I like you knowing both ways. It's the ultimate. All right. So now let's move on to another type of topic. Let's look at section communication number 3. So everybody look at problems 13, 14, 15, 16, 18, and 19. Apparently the numbering got messed up there. Okay. This involves the limits. Do you remember writing limits? This is the test that's all about limits. In fact, I think out of 8 questions, there was like 4 of them were limits on this test. So let's make sure we get limits. Well, first of all, you got to remember how this thing works. Like, let's do number 13 together. It says negative 5x to the 11th. And we decided we weren't going to try to fool you too often on whether or not the number is written in the right order. Is this one written in the normal, correct order? No, it's not. So really, we'll tell you that needs to be moved to the front. That's the lead coefficient. So now that you know that, does this graph end going up or going down? It goes down because the lead coefficient's negative. Why is that one the lead one? Because it's got the bigger degree. Okay? So technically, it should be over here. All right, since there's a negative in front, it's going down on the right. And then we also know it hits the y-intercept is where x is 0, and that makes these all cancel. The y-intercept's negative 15, so I know it touches down here. So if it's going down on the right and, degree 12, it must be going, both of them must be going down. If it's an even degreed polynomial, they're both going the same direction. And we've established, because of this negative, that it must be down. Now, there's a lot of different ways this could go, but that would be a possible graph of the situation. We know it ends going down on the right and down on the left, and it touches negative 15. Now, do I know exactly how it touches at the roots? Nope. And I don't need to, because on this question, all they want to know is what is the left end limit and the right end limit. The left end is over here, and it's lim of the function. I'm doing problem 13 right now, so you may want to write this out with me. Limit of the f of x as x approaches. If I'm left, I'm way over here where x is approaching what? What's x approaching as I go to the left here? I go further and further that way. Negative infinity, thank you. And that's equal to, well, on the function, It's the y value when I get there. If I go way this way, where's my function headed? Way that way, which is negative infinity. Okay, on the right side, lim of the function as x approaches positive infinity because I'm going way to the right. Then what's my y value when I get there? It's going way down, see, because of this. So it's negative infinity. Remember, this is an x, this is a y. Okay, that's a quick review of limits. And how about those inside limits? The limits as it approaches its vertical asymptote. All right, I'm going to give you one. If this was it, I did change it a little bit from what's on the homework there because I want you to have one to practice. Okay, so number 19, I'm doing one like number 19, but a little different. Okay, if I'm supposed to figure out its limits as it approaches its vertical asymptote, okay, well, what is its verticals? Its verticals are based on this, and vertical asymptotes are like a vertical jump. They go up and down kind of like that, you know. And this one has a vertical asymptote. I also gave you some dumb ways to remember that. Vertical is like zertical, so it's obviously an x equals thing. The vertical asymptote is at 4. The verticals come from the bottom here. There it is. There's your vertical asymptote. Okay. Now, actually, this one would be too tough. That one that I gave you, because now I can't even sketch that myself. I'm going to make that a 1. There we go. That'll be a lot easier. Okay, so now I can make a sketch of it. Do you remember that this is the butterfly one? It's not a volcano. Do you remember the volcano one has a squared on the bottom? Anyway, this one's a butterfly, the 1 over x function. The parent is this, and it looks like this. And it's been moved where? 4 to the right and up 2. So if I were to put in my other asymptote, it'd be like this. And now it's a butterfly. It kind of looks like that. Now that I have that sketch, now I can do my lim of f of x. And do it as it approaches the asymptote. So we're not talking way over here and way over here. Those would be end limits. I'm talking about right in here and right in here. Try to write your 2 limit statements as it approaches the middle. Remember, you got to say x approaches 4 from the left and x approaches 4 from the right. This is how every limit statement looks. Okay, the limit as x approaches 4. And then how do I say from the right? Well, when you're way to the right, you're where x is positive, so you put a little plus up there. That's from the right. And then from the right means I start over here and I start approaching, and I'd have to ride this train track, and it forces me up. Raise your hand if you had that one right. Okay, good. Then the other one is the left end, and that's approaching from the left. So you're from over here, and if you ride this train track, you're going to be forced down there. Negative infinity. Any questions on those limits? All right. You guys have been paying attention really well, and I think I can just push through and get to the last part. Let's talk about graphing. Everybody go to problem 21. So you're supposed to graph that one, and it starts with this, 1 over x plus 5 squared, and then minus 4. Remember me talking about the butterfly and the volcano? Which one's this? This one's the volcano. Okay? The butterfly is not squared. If this didn't have that squared on it, that would simply be the butterfly one, which is the 1 over x function. But anyway, this one has a squared on it, so it's a volcano. So generally, it's looking like that to start with. And now where do we shift it? We shift it 5 to the left, and where? Down 4. Now, if you're not awesome at being careful, you could screw this up pretty easy. Here's the parent spots. I already was pretty sloppy in mine. So I'm going to go back and be more careful. So if those are the 2 parent spots, the volcano needs to go through them. Okay, now where should I shift it? 5 to the left, including those little spots. 1, 2, 3, 4, 5. There, and then -4, down 4. 1, 2, 3, 4. There we go. If I put in my asymptotes, one of them's pretty obvious. I hope the other one's pretty obvious to you too. And there we go. I've graphed it. Now, what's your best friend in graphing? XY chart. If I just check like one point and make sure it's on there, wouldn't it be logical to check one of your main points that's like one of these points? And they were shifted 4 to the left. So if I did that correctly, actually I shouldn't have put in those dashes like that. If I'm going to check that point, it's been shifted 4 to the left, then it's actually been moved over 3 this way, plus the one that was already there. So that's where it was. So it's gone 4 to the left. Okay, so I would say, does x equals -3? -3. I stick in a -3 on my chart and see if it works nice. Okay. -3 plus 5 be 2. 2 squared. So I think there's a number of marks wrong again. Yes. Yes, it's supposed to be. Yeah, this is supposed to be 5 to the left. I should have used, on my next hour, I'll use a graphing paper to do this because I got myself confused between my 5 and my 4. So if so, there we go. That's being shifted 5 to the left. So I was doing my up, down, and so my left, right. Okay, so now, okay, so then -4. But you know what? That just saved me a point on the test because I was like, wait a minute, this isn't working. And then I figured out that I had labeled this wrong. You know, I had the wrong number of dashes on my thing, so I had shifted it the wrong number to the left. Anyway, now I'm going to put in a -4. Now I bet it works. -4 plus 5 is 1. 1 squared is 1. 1 divided by 1 is 1. 1 minus 4 is -3. Is this spot at -4, -3? I think you could make the argument that it is. Pretty close anyways. Okay, so moral of the story, if you want a good grade on this, I still only have about half the kids actually using an XY chart to check themselves. And I think that's only because, generally speaking, the graphing test is the easiest one, and people feel confident. But if you're not sure, it's been a while since we've done this, I would throw in an XY chart to double check yourself on any graph that you're supposed to do. All right, let's talk about one last kind, and that's like number 24. Very last problem in the packet. It says graph showing the intercepts, which implies both x and y intercepts, are important, and behaviors of I think, yeah, I did actually the wording on this, and I worded that badly at the end. And behaviors of the graph at the correct, yeah. The formatting got all messed up, and what it did is wrapped around to the other column. So what I meant to say on problem 24 is graph showing the intercepts and behaviors and behavior at the correct x-intercepts. If you just change the word of to the word and on problem 24, please change the word of to the word and I think it'll work. And behaviors and behavior at the correct x-intercepts. Okay, so anyway, let's do 24. Can you see, since it's already been factored, that I know the roots? I know it hits at 3 and -6 and -2. For those at home that don't have this problem in front of them, I know that this thing has to hit at positive 3 because of that. I know it has to hit at negative 6 because of that. And it has to bounce there. And here it has to be a snake at positive 2. That's the snake right there. Okay, and I also know that the lead coefficient is positive, so it must be going up on the right because there's no negatives in the front of this thing. Okay, so it must be going up on the right, and the total degree is 3, 4, 5, plus 1 for that makes degree 6, which means they both go together. They're either both up or both down, and since we established that the right side's up, the left side must be up. Okay, how do I do this? I'm going to cut through here, snake through there, that's an awful snake, and bounce off of here and then go up. And I just have to go back and like clean up the snake a little bit to make that look better. Okay, so what am I supposed to do with this now? Have I got the correct x-intercepts? Ooh, it does say the intercepts. That implies the y-intercept too. So what is the y-intercept on this puppy? Fill in this sentence. The y-intercept is where? Come on, answer that question. X equals 0. Good. If the y-intercept is where x equals 0, I put in a 0 and a 0 and a 0, and I figure out where it is. That's going to be big. Negative 3 times 6 squared is 36 times negative 2 to the third makes negative 8. That's important that you know that that's negative. That's a plus 2 at the end. Did I just copy the problem wrong? I did. Thank you very much for catching that. Okay, so then it's positive 8. Okay, so now I have to multiply all those numbers together, and I get a huge negative number, which means I did something wrong. All right. But the good part is it's really good that I checked. Check my y-intercept. Okay, the y-intercept, wouldn't it be a huge negative number? Do you agree with that? So something's wrong with the 2 on the graph? Oh, since it's a positive 2 here, it must be a negative 2 on the graph. Thank you. All right. Little pieces. It'll help come together to figure this out. So it was positive 3 from this. It was negative 6 for the bounce. And it's supposed to be snaking at negative 2. So through that point, it's supposed to snake. All right, it's bouncing up here. Snake. And that's how it hits down in the negatives. Yay. This is a snake. Okay. And now this is some big negative number, and yay, it matches up. See? Every little thing you can do to check yourself. Okay, I checked my y-intercept, and that caught a little mistake that I had made. So now I'm going to go through all my directions, and this is what you should do too. Look back at the directions, because we have to be picky. If it says to show the intercepts, that implies both y and x-intercepts. I've labeled them, except for that I should label is whatever that huge negative number is. You should label it, I don't know, negative 512 or something. Anyway, and I should show the end behaviors. Yep, I have my end behaviors on here. And I should show the behaviors at the intercepts. Yep, I got this bouncing, this snaking, and this cutting through. So those are all good. So I encourage you to read the directions on the test and make sure you've done everything it says, because you could have an answer that's great until you realize that, oh, it needs me to give the actual y-intercept. Yeah, your y-intercepts are important. Don't show the y-intercept, I have to mark it wrong. Okay, so on number 23, I would not expect you to be able to factor that. And I would want to call your attention to, on number 23, do you get that there's a x to the 9th as the second term? So that's the lead coefficient. Maybe you want to circle that on number 23. Circle the plus 6x to the 9th so you don't get misled, because that's the biggest degree on number 23. Okay? All right, I've covered a lot of stuff. Now you need to go back and figure out where you're having trouble. Tomorrow, thankfully, is a Tuesday, and therefore I am available in the mornings if you want my help. So you could come in tomorrow morning before we take the test. Test is tomorrow, And last thought is it's a cumulative test, which means that you can use this test to be corrections. There weren't too many people that bombed things, and if you were one of them, you'd want to come in the morning tomorrow, so you'd have make sure that you've signed off on anything that you think you want to retake. Remember, my advice is don't mess with B's. Unless you're always an A student, I wouldn't be thinking about changing B's. I've had too many kids do worse than they thought on the cumulative and actually change their B down lower. You don't want to lower anything. So I would only be thinking about C's, D's, and F's. If you got a C, D, or an F, and you're normally a really good student, I would think about using this as a correction opportunity. All right, so here's your tests. I need to get those back to you. And that's all I have to talk about for today's video. I'm not going to try to squeeze in anything on the most recent test. That, if you want to see that, look at the review video I did on Thursday of last week for that algebraic manipulation test.